Welcome to Crunchlabs. I am so stoked that you're here. In case you don't know, my name is Mark Rober, and for over a decade, I've been making videos on YouTube where I use my engineering skills to make some ridiculous builds while having fun and teaching some science at the same time. Alright, so the deal with Crunchlabs is not only every month do you get this amazing toy that you get to build and put together, but then we get to talk about the juicy science behind how it actually works. I want to help foster in you a love of science and the amazing world around us because it's such a lovely lens from which to experience life. And the goal of the build box isn't so that you don't have to take high school or college physics, although I am going to expose you at least to a high level all the same principles that you'll learn there. It's more about giving you some of these aha moments where you level up your understanding and getting a sense of just how cool that can feel. That's partly what it means to think like an engineer, just like it says right here on the box. It's about being curious about the world around you. And if I could take that curiosity and turn it into a craving, so you crave knowledge, you crave those aha moments, just getting your hands dirty by trying and making and failing, but then coming back more resilient and stronger, having learned. If you could do that, if you could capture that, you just have a lifetime of really fulfilling learning ahead of you. Okay, so for this first lesson, since you don't actually have a box in your hands yet, my thought was that we could take this welcome letter and turn it into a paper airplane. But not just like a generic boring airplane. I'm going to teach you my favorite airplane. One that glides amazing so that when you're together with friends and you're like having a competition, the one you fold will just dominate all the others. Specifically, at least for today, what I want you to understand is that the air around you is a fluid. Just like water is a fluid, it's just way less thick than water. But it behaves in the same way as water in a lot of ways. So for example, if you're in a pool or the ocean or something, and you want to move your hand quickly through the water, you want to move your arm like this. In which case do you move faster? When your hand's like this, or when your hand is turned 90 degrees, and you move it like this? Let me ask you another one. If you want to move through the water as quickly as possible when you jump in, should you do a pencil dive to go into the water? Or should you do a cannonball or a belly flop? Well, in both cases, I think you'd be like, well, a pencil dive. If I jump up and I act like a pencil jump in, I just cut right through the water. And if I move my hand like this versus this, I have it side like this, it really cuts through the water. And that's the right mental model. You really are cutting through the water. The water has all these little tiny water chunks. We call them water molecules. And if you do it this way, you kind of cut through those. Versus here, you're kind of bluntly pushing them all out of the way. So it just requires more force to kind of push all those out of the way versus kind of slicing through them. Well, air is also a fluid, so it behaves the same. There's little tiny chunks of air all over the place that we call air molecules. And just like with the water, you can cut through that air and you'll go through the air quicker. So I've got this piece of cardboard and you could test this yourself. If I try and move this as quickly as possible in this orientation, that's as quick as I can move it right there. You can see it pushing all of these air molecules, these little air chunks out of the way, right? We call that drag. There's a lot of drag. But if I turn it 90 degrees, what do you think's gonna happen? Now I can move it back and forth super quick because it's slicing through all that air. It's like a knife through butter. Instead of mushing the butter, you're slicing right through. And you could test this with your own hand with your parents' permission. You could stick it out the window. You turn it this way, you really get a sense that air is a fluid. All these air molecules are bumping into your hand this way. When you turn it this way though, it just slices through it. There's so much less resistance because you're slicing through it, just like your hand through water, just like a knife through butter. So now that we have that understanding, my tip for the day here for when we make our paper airplane here is I've got a little Crunchlabs pen and it's made of hard plastic. It's kind of rounded. I'm going to use this to really help me make nice crisp folds with my paper airplane, especially on this front edge, because the sharper it is, the easier it's going to cut through the air, the less drag it has, and the farther it will go. So you'll see me use this as I'm folding over this paper airplane to really go over the folds, make them nice and sharp and crisp, because that's going to help it go farther. All right, so with that, let's walk through the folding steps for our paper airplane. First, print out your certificate of enrollment. Then start by flipping it upside down. We're going to take the upper right corner and fold diagonally across so that the entire top edge is lined up with the left side of the page. Make a crease and then unfold. Next, we're going to repeat that same process on the left side, so we fold diagonally across so the top edge meets the right side of the page. Go ahead and make a crease, and then after that, unfold. Next, flip the page back to the front side. There should be a nice X going across the page from the last two folds. Take that top edge of the page and fold it down so the crease passes through the center of the X, then make a crease, and then go ahead and unfold. Bend the paper a bit to pop the center of the X up. Then flip it to the back side. Fold the top corners down so they meet the other folded edge and crease everything. If you've done it right, it should just make a nice triangle like this. Then take the sharp corner flaps and fold them towards the apex of the triangle, making a diamond. Then crease it all down. Then grab every layer of paper at the top point of the diamond and fold the point down to the bottom of the diamond. Then crease the new top edge you just made. Now flip the plane so the printed side is up, and then fold the plane in half so my signature touches the QR code. Now crease the center line. Next, fold down each wing along the dotted lines. And be careful to make these folds symmetric, even if you stray from the dashed line, because this will help to give you stable flight. To finish up, fold up the flaps on the ends of each wing, then tuck a little corner at the back of the plane, just like this. Alright, so now that this is looking pretty good, like any good engineer, we need to test it out. So let's head over to the arena. And as you can see, it just glides and flies like a champion. Here's a pro tip. If you want to adjust the flight path of your plane, try gently bending up or down the back edge of the plane near the center fold. If you bend it one way, it will have more level flight. Bend it the other way, and you'll get more of a loop-de-loop. Alright, so a big part of these monthly videos is me reminding you that engineering is an iterative process. Some of the best moments you'll have with your Crunchlabs build box will be when you fail a bunch, but then because of that you're learning fast and making new prototypes and trying new things, and then you finally hit that big breakthrough. Yes. So how can you take this build to the next level? Well, I would start by just tweaking it and getting it just right to fly exactly how you want to fly it. Maybe you could do some research on some other paper airplane designs that you like and compare them to this one. Test them both out, see which one flies farther and the best way to throw each one. Certainly, I would at least memorize how to build this one, so next time you're together with like a paper airplane building competition, you can just whip this out from memory and totally dominate. Direct tip. Most importantly, if you got the welcome letter and you're watching this video, you need to get pumped, because that means we're working hard on packing up the build box with your name on it, and we'll be at your door real soon. Okay, so go have fun, run some of your own experiments, and then I'll see you real soon with your first box in hand right here at Crunchlabs.